In the last few decades, we've discovered quite a lot of amazing planets out there. Exoplanets that seem to exist pretty much everywhere in the universe. But can these planets exist around black holes? Hello wonderful person, this is Anton, and today we're going to discuss the idea that was recently published in one of the science magazines that investigates the idea of planetary formation around supermassive black holes and also discovers something really incredible about them. Let's talk about this and welcome to What the Math. Naturally, you would expect black holes to have quite a lot of planets, because when a star gets captured by these black holes, their planets would also get captured as well. In this case, if we were to place planet Earth and of course our Sun in the orbit of Sagittarius A star, relatively close to it, it almost instantly gets captured by the black hole and becomes the black hole's planet, not really the Sun's planet anymore. And you can confirm this by looking at the orbits of these objects. So this is not something that we don't expect, this is pretty obvious. But can planets naturally form around black holes from all of the material orbiting here? In other words, can the gas orbiting the black hole at farther distances from the black hole form into tiny objects that can then become planets? Well, last year we've discussed a study from Japan that theorized the possibility of planets around black holes. And the suggestion here was that, well, yes, it's quite possible for black holes to form their own planets. But the follow-up study that you can find in the description below goes into even more detail about the formation of these planets and also discovers how big and how massive these planets can get. And just like a lot of other concepts that were proposed in the last few years that had funny names, like for example moons or moons of moons or planets, which are planets that used to be moons but became planets because they were captured by the star, the scientists behind this paper propose a new name for these planets as well: Blanets, so like black hole planets. And the idea for the planetary formation here would be somewhat similar to a planetary formation around a star. So here, if we were to look at a typical protoplanetary disk where planets form in the beginning of a solar system or any other star system, today we believe that the majority of planets form in the region where the tiny particles can actually coalesce first, so in the colder regions of the star system. And the coalescence between these particles actually happens because of the electromagnetic, or technically static, effects. In other words, static electricity that's responsible for causing this to this poor cat is also responsible for bringing the tiny particles together in the beginning of the star system to form larger and larger particles, usually around this big, before they start using gravity to attract each other and to collide. But the problem with the region around black holes is that, well, if the velocity of these particles is too high, then they will not be able to collide with one another without really repelling each other too much. At the same time, if the velocity is too low, or if the particles are too far apart, they'll never really attract each other to begin with. So all of these questions need to be addressed mathematically in order to see if it's truly possible for a supermassive black hole to possess its own homemade planets, planets that were made around the black hole. And the discoveries from this paper suggest that black holes might be even better at forming planets than typical stars. First of all, in terms of the actual mass, they do possess a lot more material that's able to create planets. In other words, all of this dust orbiting the black hole already has so much mass in it that it can definitely form stars, not just planets. Although this is a little bit misrepresentative of what I'm talking about here. We are talking about the area not really right next to the black hole where the accretion disk is, but much farther away. As a matter of fact, far enough away that the black hole itself becomes more or less invisible. So kind of like right here, a few light years away from the black hole that still has a lot of different gas orbiting here, and some of this gas in front of the black hole actually makes the black hole practically invisible. So all of the dangerous radiation that's coming out of the black hole would actually be absorbed by all of the gas between the planetary formation area and the black hole itself. Now this region here is also cold enough for the particles to start slowly coalescing and to then start gravitationally attracting each other. They're also not moving that fast here, so the actual accretion and collision between smaller objects starts to happen pretty much across the entire area far away from the black hole, and this process is probably very efficient as well at creating various objects. Most importantly, Unlike in a star system where there's a lot of gas that eventually slows down the planet and basically creates opportunities for this planet to collide with the star or collide with something else, in a typical supermassive black hole system, the distances here are way too large and there's almost no opportunity for these planets to ever come close to the black hole. So the chance for their survival and potentially even evolution are extremely high. And this creates a perfect opportunity for these planets to form. No dangerous radiation, distances that are far away from any potential collision with a major body, and most importantly, a lot of dust available for absorption to increase one's mass. But not all supermassive black holes can create these conditions. According to the scientists behind this paper, a black hole that's too quiet, so kinda like the black hole in the middle of our own galaxy, will probably not have good enough conditions to generate enough material for these objects. And an active galactic nuclei galaxy that's too active will usually have way too much energy and way too many galactic winds coming out that will probably destroy any potential planets as well, or destroy their chance from being created. So this has to be something in between, not too active, not too quiet. So a somewhat quiet active galactic nuclei that can last for about 100 million years will produce just the right conditions for these planets to suddenly start forming, and most of them will form within only about 70 million years after the galaxy becomes active. And what's more is that their calculations suggest the planets here have a chance of being gigantic. Actually, it's more likely that they're gigantic compared to some of the other planets we've discovered so far. Because there's so much mass everywhere and because the collisions here will happen pretty much consistently for millions of years, these planets will reach masses of close to 3,000 masses of Earth, or possibly even more massive if the black hole is larger. So it really depends on the size of the black hole and how much material it already has orbiting around it. Interestingly, this object right here also seems to possess water. This is very unusual, but that's because I created a really large ice object of about 3,000 masses of planet Earth, and it got warm enough to actually have liquid water conditions. So we don't really know what these planets are like. We also have no idea if any of these planets can ever be habitable, but right now we just don't have any means of detecting them. It's a very theoretical model, but it does have a lot of math behind it to support the existence of these planets. But one of the major questions right now would be, well, okay, can we find a way to detect them somehow? Is there any way that we could find something that would suggest whether this theory is correct or not? Well, the scientists behind this paper indicated that larger black holes will produce much larger planets, and some of these planets might even become brown dwarfs. And some of these brown dwarfs, these larger Jupiter-like objects that are not stars yet, can eventually reach the mass potentials to become stars. In other words, if one day we detect a relatively small red dwarf in orbit around a typical black hole somewhere out there, a red dwarf that might possess certain very unique and unusual features indicating that it used to be a brown dwarf, in this case, this would give us a definite indication that planetary formation and even star formation is possible around typical supermassive black holes. Although right now it would be very difficult for us to actually observe these very far away regions using modern telescopes. The only region we can observe in a lot of detail is the one around our own galaxy, and our galaxy is no longer an AGN. We don't actually even know if it was an AGN before. But the thing is, if it ever was an AGN, and if it had the potential to create these planets and these stars, we might be able one day to discover them in the orbit far away from the black hole. So the detection of unusual brown dwarfs or red dwarfs in this region would definitely help this theory become a reality. But even the theory itself is pretty convincing. It suggests that these larger black holes can create thousands and even tens of thousands of planets in their vicinity, and some of these planets, or actually most of these planets, are much more massive than the ones we find around typical stars. In other words, the idea behind Blanets is very solid. So now we just need some sort of actual physical proof and observations, because without the observational evidence, it's still just a theory. But other than that, that's kind of all I wanted to mention in this video. You can check out the paper in the description below, and you can also check out the video I made last year that sort of presents another paper about this topic as well. Thank you for watching, I'll see you tomorrow, come back tomorrow to learn something else, maybe subscribe, maybe share this with someone who loves learning about space and sciences, and maybe support the channel on Patreon or by buying the Wonderful Person t-shirt you can find in the description below. Either way, space out, and as always, bye bye.